This example, we are going to be looking to do the derivative of this kind of complex looking trig quotient. And then once we do our derivative, we're creating the derivative equation and then go ahead and plugging in 4 into this. So we'll be using a calculator for this, but we need to do the derivative. So the first thing that stands out to me is this thing looks like very much like a quotient rule, right? And so really don't want to do a quotient rule if I can avoid it, but sometimes I can't. So, but the world of trig can allow me to do a whole lot of potential substitution. So sometimes I can avoid quotient, especially with trig. So let me rewrite this and see if we can make this so we don't have to do quotient. So if we start this, let's manipulate this thing. So if we have a 2x squared tangent, it's this that I can rewrite. So I can rewrite secant as 1 over cosine. Now, that doesn't seem like that made it any better. It looks like it made it worse. However, instead of dividing that fraction, I can multiply by the reciprocal. So I can take that tangent, and since I went to a cosine sine kind of a world on that, let me do the same thing with the tangent. So if I rewrite tangent into sine over cosine, and then instead of dividing 1 over cosine, I can multiply by its reciprocal. Cosines go away, and I now am actually doing a 2x squared sine x, which is something that's definitely easier to do the derivative. I don't have to do a quotient. I don't have to do tangent. Tangent is more complicated at a derivative, and so is secant. So this is much nicer. So let's rewrite our original function of 2x squared plus sine x. Plus, sorry, 2x squared times sine x. All right, and then we'll look to do the derivative. So we do have a product rule, right? We have this piece times this piece. So we're going to be taking the derivative of the first. So the derivative of the first is 4x times the second plus the first times the derivative of the second. So plus 2x squared. Derivative of sine is cosine. All right, that is our derivative. There's nothing really we need to do to manipulate that. Maybe we can take a 2x out, but that really doesn't make anything any better. So that is our derivative. And then we are asked to find the slope at 4. So we would be plugging in, so 4 times 4 times sine of 4 plus 2 times 4 squared cosine of 4. All right, so 4 is not any kind of an angle that's very nice at all. It doesn't have a degree symbol on it, so make sure you're in radians. And then we're just going to throw that into the calculator, round it appropriately, and see what we get. So I already kind of set it up that I plugged that into the calculator. I made sure I was in radians, and I have my 4, my 4, my 4, and my 4 that's all plugged in, and I get a negative 33, negative 33.0254. 0254. All right, and that is us being able to manipulate a trig problem because trig has way more types of possibilities of substituting in for different values, and maybe we have created a problem that's easier to work with.